All right. So this is what we were looking at. This 5 degree was the conversion angle.
Yes.
Okay. And conversion angle was convergency divided by
Oh,
2.
two.
We are
Okay.
happy till now.
Yes.
If I ask you what is the value of convergency, what will be your answer?
2.5.
No, it will be 10. 10 degree. 5 degree is equal to convergency divided by 2. Just send this to that side now.
Okay.
Convergency is
Okay.
5 into 2. Convergency was 10. So that's why when you divided it by 2, the result was 5, which was the conversion angle.
Yes.
Okay. So we got the value of this part A, B, C. We know convergency is now 10 degree. Good so far?
Yes.
Now
Yes.
let's move to part B. We are asking from line track from B to A. And I gave you from line track from A to B. This is 1 to 0. But I want to know what is B to A. The value of B to A. What will it be? If I say you
It
go
will
in the
be
east direction, 0, 9 or 0. You wanted to go from point A to B at 0, 9 or 0. You went from your home to a place B. Now you followed the direction of 0, 9 or 0. But you want to come back to your home also, na? So you can't continue following 0, 9 or 0 to reach your
yeah,
home.
it will
Now you will follow the direction of 270, right? Completely opposite. Did you get it? You were going from point A, from your home to a point B, following a direction 0, 9 or 0 towards the east. You reached here. Now you want to go back to your home. You will exactly do reciprocal, na? From where you came. So you just added 180 degree. 180 degree to 90. So you are going exactly opposite.
270. Okay.
270 degrees, right?
Yes. Yes.
So now you went from A to B. When you went from A to B, the direction was 1 to 0 degree. Coming back from B to A, you'll add 180. You'll add or subtract 180. So here we are adding 180. What was the simple formula I told you to add or subtract? If you want to add 180 plus 2 minus 2 and nothing. Plus 2 plus 1,
3,
3.
4.
2 minus 2, 0, 0. So if A to B the direction was 1 to 0 degree, then from B to A the direction is going to be
Yeah. 300.
300 degrees, right? So the drumline track from B to A is going to be 300 degrees. Let's move to part A. You have to tell the great circle track from B towards the A measured from B, right? From A, when you're going towards the B, the initial great circle angle is already given, which is
550.
115. Okay.
Okay. Okay. 1 1.
If this angle is 5, this angle is also going to be 5. There are n number of ways to solve this problem. Okay. We'll discuss two of them. How can we solve this particular problem? This angle is 5 degree. This angle is also 5 degree. This direction is 120 degree. Then this direction is 300 degree. We just found it out, right? Now tell me, okay, starting from the north, we start our calculations like this in the clockwise direction. This is a particular angle, say 300 degree. This is 5. What will this angle be? This much? 305.
Yes.
Now, if I have already given it, although it is not 305, it is 270. I'm just making a visual diagram. If it is 305 and I tell you that this is 5, this one will be 310. Just added 5 more, right?
5 more. Yes.
What happened?
Yes, ma'am.
Okay. So this was 300 degree. This is 5 degrees. How much will this angle be?
Three
How
zero
much will
five.
this angle be? Perfect. This angle will be 305 degrees. This is what the question was asking. They wanted to know the great circle track from B to A. This is B, this is A. B to A is this direction. And they want to measure it from B, obviously. We knew that rhumb line is 300 degrees. Conversion angle you only told me it is 5 degrees. So here 5, here also 5. 300 this
5.
thing. 5 is this thing. This is what we wanted to know. So we found out the angle is 305 degrees. Happy? This is 305.
Yes.
Now, there is one more approach to this question. When I say that GC final, the great circle track final minus great circle track initial is equal to convergency. That means this is my rhumb line, this is my great circle track, this is my initial track, right? And this is my final track. Okay, A
Yes.
to B. This is my initial great circle track. Why did I say it initial great circle? Why did I not say this? This is the initial great circle. Because this is the run line. Do not confuse it while making diagram that the initial great circle is given like this. So you don't take this direction. Great circle is the curved line. So
Oh,
initial great
okay.
circle means the place from where you started. Great circle at A, right? So that means great circle at B minus great circle at A should be equal to convergency.
Yes.
Okay. The initial great circle track was given. How much was it?
Initial 115.
Yes. Do you know the final? No. So GC final, we don't know. Minus initial was given
115.
115. That will be equal to convergency. What is the value of convergency? You only told me
5.
5 was conversion angle.
Okay, 10.
Yes, perfect. Convergency was 10.
10.
So GC final, or you can say GC A to B at B will be
125.
115 plus 10. Perfect. 125. So good so far. This direction A to B at B, from A to B seen at B, this angle we found out 125 degree. How is this 125 degree found? What is the meaning of this 125 degree? 125 degree means from here till here. This is 125. 115 here meant drawing a north here. From this north, this much angle is 115 degree. Okay,
Yes.
good. So we found out GC A to B at B is 125 degree. But what was the question asking? B to A, right?
Wait.
So if you did B to A, the direction would be like this, completely opposite of what it was, right? Any doubt? This is what we found
No.
out by this formula. GC final minus GC initial equals to convergency. So we found out the GC final that was A to B, but at B, which was 125 degree. Now I want to find its opposite direction. What is the opposite of 125? Plus 2 minus 2. What will it be? Plus 2 plus 1.
305.
Perfect. Did we find the same here? Did we get the
Yes.
same value here?
Yes. Yes.
So there are two ways of solving. Either you take the rump line, just add or subtract the conversion angle, and you'll know the value of your great circle time. Okay. Or you can apply the formula and then solve the question. Alright. Now we have to see this thing. What happens in the northern hemisphere? What happens in the southern hemisphere? Till here we are done. On Mercator chart, great circle is a curve.
Con-
We have seen great circle is a curve. Happy about it. And we are talking about charts. Convex nearer to poles. If this is pole, this direction is convex, right? Towards pole it is convex and equator is here. Towards equator it is
Okay.
concave. No doubt till now. Whatever the line is saying, this is saying correct only. Great circle is a curve, convex near to pole and concave towards the equator. Drum line is always nearer to equator. That's why we draw drum line below and great circle above. So which one will be nearer to equator? This is equator. This is pole. Who is nearer to equator? The drum line or the great circle?
From line.
Very good. It is nearer to equator. So this is exactly what has been written here. Right?
Yes. Yes.
Now, in the northern hemisphere, the direction of westerly great circle decreases. The direction of easterly great circle increases. What is this here? Very difficult language. Do you agree with me? Do you agree with
Yes.
me? This is a difficult language. Let's make it simpler. First, tell me, are you clear on the fact that in northern hemisphere the diagram would look something like this? This is
Yes.
the rump line. This direction is this direction. This is the rump line. This direction is going to be a great circle. Very happy about it.
Yes.
Okay, good. Now, in the northern hemisphere, I want you to move in the east direction, in the eastern direction. What do you mean by eastern direction? 000 degrees to 179 degrees.
Yeah. Yeah.
The eastern direction. This is the drum line. This is the
Great.
great circle. No doubt in that. We
Mm.
are going towards the eastern direction. That's why we are moving like this in the eastern side. Happy till now.
Yes.
Whenever we measure angles, we measure it from whenever we measure any direction, any angle from. So what is the
From
reference
north.
point? Very good. This was our
North.
point A. This is our point B. Going from point A, let's find out with the north. This is what initial track is making. This is the angle which the great circle initial track is making with the north, right?
Yes.
Let's move at point B. Again, I drew the north.
North.
Do you see? This is how the track is going, right? Initially, it is making this much angle, and finally, it is making this much angle. So, can I say that whenever in the northern hemisphere, NH is the short form for northern hemisphere. Whenever I'm traveling in northern hemisphere, in the eastern direction, right?
Yes.
My great circle bearing, we'll discuss it in next class. What is the bearing? What is the track? What is the heading? Increases. My great circle track, or you can say my great circle bearing, is increasing. Why? Initially, the angle was this much, and finally, the angle became too much, right? We can see it visually also.
Yes.
Now, instead of eastern direction, let's move towards the western direction. In the northern hemisphere only.
Okay.
So the diagram is going to look like this. Northern hemisphere diagram will be this. Thumb line below and great circle above. Western direction means going from 180 degree to
359 degree.
359 degrees, right?
Yes.
Now, I am traveling in this way, in the western
Will be.
direction.
Okay.
Are you happy with the diagram? Going from point
Yes.
A to point B.
Westerly direction.
This is my trajectory from A to B. Again, let's see the angle from north. Okay. Now tell me, where should I draw my circle? From where should I measure the direction? From the true north. This is the angle.
Yes.
Yes, this is not the angle. Why? Because we discussed that whenever you are measuring any direction from the true north, it always has to go in the
Clockwise direction. Okay. Okay. Okay.
right. So you'll start from here, going like this, and reaching here now.
Okay.
Okay.
Yeah.
So you're going from point A. This is the track you were making initially. You reach a point B. This is the true north. From here you will measure angle. Again, should I go like this?
No. It's
No.
clockwise. Yeah.
Very good. Clockwise direction. This is what it is making finally, right?
Yes.
Now look at the diagram and tell me, did the angle increase or decrease from A to B?
The angle got decreased.
Yes, it was decreased. That means the great circle track was decreasing because this is a great circle initial, this was the great circle final. So we saw that the track decreased.
Yes.
Are we happy?
Yes. Yes.
So I can say in northern hemisphere, if I'm going in the east direction, not my point, I'm saying east. In northern hemisphere, if I'm going in east direction, my great circle
I
track will increase.
increase.
This is the diagram for it. From A to B in the east direction, the angle was increased.
Increased.
But in the northern hemisphere, if I go in the west direction,
West direction
this angle
decreases.
will decrease.
Decrease.
Happy about it?
Yes.
All right. So you can even remember it from this diagram. In the northern hemisphere, if you're going towards the east direction, the great circle tracks will increase.
Increase.
In the northern hemisphere, if we are going in the west direction, the great circle tracks are going to
Decrease.
decrease. Happy with the northern hemisphere.
Yes.
Now let's talk about the southern hemisphere. If the name comes southern hemisphere, do not put your brain, do not do anything else, just draw this diagram first. Okay? This is the rump line, this is the
Great.
great circle. Southern hemisphere. Let's talk first about the eastern direction. Eastern directions are from 000 degrees till 179 degrees. Okay? So we are traveling in the eastern direction, southern hemisphere. As the name suggests, southern hemisphere. That's why we made a diagram where the great circle was below.
Yes.
Eastern direction. That means we are going like this.
Yes.
Happy? All right. This is your point A. This is your point B. Because we are going in the eastern direction. From point A, if I measure the initial track, it will be this one because I'm talking about the great circle tracks and not the rhumb line. That's why we are not considering, we are not just stopping our angle here, right? So this
Yes.
is my initial track. I started from here, I went straight to the point B like this, right?
Mm. Yes.
Now let's look at point B. This is my north and this is my angle, right?
Yes.
See a small angle at B. So, in the southern hemisphere, when you went in the eastern direction, did the angle increase or decrease now?
Decreased.
Very good. What is the, why am I mentioning the term angle? It's not actually angle, it is the track. It is the great circle track. Initial track was this big, the final track was small. That means the track decreases in the southern hemisphere when you are going towards the east direction.
Yes.
Again, we are in the southern hemisphere, but the direction is
West.
west direction. 180 degree to 359 degree. What will you do? First of all, draw a straight line.
Right. And great circle.
Good. Happy?
Yes.
Okay, this is the diagram. Now we have to go in the west direction. West directions are these directions only, right? That means I'm traveling like this from this point A to this point B. Okay. At point A, what is my track angle? This is my track angle. Okay. See this line. Just extend this line and you will understand which angle is which one. This is my direction at B. Let's make a true note and calculate this angle. This is my angle at B. What is the angle? The GC final, the great circle final track of the great circle bearing at point B. Do you see the difference?
Yes.
Is it increasing
Is
or decreasing?
increasing.
Perfect. So can I again make a note that if I'm going in the southern hemisphere in the eastern direction, my track will,
Decrease.
if I'm going in the southern hemisphere in the western side,
And then
it
actually
will
it increase.
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 So these are the points you have to remember. North, east increase, northwest decrease, southeast decrease, southwest
So
increase. You can remember it via this diagram also if you find it comfortable. Or I
yes.
just remember this one, just one. Honestly, I just remember this one. North, east increase. Then what I do? North, east को you will change in west. If you are changing any one thing, yes,
Decrease.
it will decrease. Similarly, I started with north, east increase. Even if I change any single digit from this place, the word will become opposite. If I just write south instead of north, again it will change into
Decrease. Okay.
decrease. Now taking SED, south. If I change east to west, again it will change into,
Increase.
this is how I remember. Yeah, I just remember this one, I just change one word and this thing changes. Again, if I change this thing, then north to south, east to east, then I will become decrease. Southeast, if you write southwest, then again it will change. Or if you find this diagram helpful, then you can use this one. You can just make an earth. This is your equator. This is the northern hemisphere. This is the southern hemisphere. This is the east direction. So you can write I. And then just make your thing. I, then D. I, then D. Then I. Northern hemisphere, east direction increase, west direction decrease. Southern hemisphere, east direction decrease, west direction increase. So whichever
Yes.
way you find it easier, you have to remember it. This is a memory
Yes.
thing. And this will be asked in questions in the same way which I have asked you in this question. They'll give you rung lines, they'll give you GC tracks, they'll ask you anything. It's GC initial, GC final, convergency, convergent angle. All of these things will be covered here from this part. See, the diagram is also given. In the northern hemisphere, this is the rung line, this is the great circle track. If they are going from point A to B at a rung line of 090 degree, initial track is 030, final track is 150. Okay, so the diagram looks like this. Similarly, in the southern hemisphere, this is equator, this is great circle going in the eastern direction. The diagram will look like this. Going in the western direction, the diagram will look like this.
Yes.
Okay. Huh. These are the questions which you have to practice. All right. But before moving to these questions, we'll solve few more questions, at least two or three, and then we'll move forward. Again, let's ask you if the rum line track is given, A to B is 060 degree. and convergency is 15 degree. Okay, you are in the northern hemisphere. It will be given. It will always be mentioned. Where are you? Or if it is not mentioned, they'll ask you. Okay, they'll give you all the details and ask you in which hemisphere are you. Right now, I have given you that you are in the northern hemisphere. Drumline track from A to B is 060 degrees and convergency is 15 degrees. You have to tell me great circle track A to B at A, great circle track B to A at B, great circle A to B at B, great circle B to A at B. You have to tell me the rum line. No, yes, rum line. Rum line from B to A. You have to tell me the conversion angle.
Actually, Northern Hemisphere will be given in question, or we have to find it based on the
It
degree.
will be, it will be given in the question. In which hemisphere
Okay.
are you? If it is not given in some cases, if the hemisphere is not given, then they will be asking you. They will give you some other details and then they'll ask you, okay, tell me in which hemisphere are you? We'll go forward to those questions. Let's solve the basic ones first.
Okay. Okay.
Run line is given A to B 060 degree. Now tell me, in the northern hemisphere, are we in the east direction or are we in the west direction?
We are in the east direction.
Perfect. So my diagram would look like this. A to B. Run line between A to B is 060 degree. Where should I make this diagram? At position 1 or at position 2?
Position one.
Very good. This value, the run line, is given 060 degree. And what is the convergence given?
15 degree.
If convergence is 15 degree, can I say my conversion angle is
7.5.
very good? This will be 7.5. That means this angle is 7.5 degree. This angle is also 7.5 degree.
Yes, ma'am.
Now you try to find these values and tell me your answer. Then we'll continue forward.
52.5.
Okay. 52.5 is what?
60 minus 7.5.
Yeah, that I know 60. You did a correct thing. But what is this? Out of these, one, two, three, four.
Yeah, from B to A, ma'am.
B to A. B to A will become something like this, sir. B to A. This is 60. See, this is a great circle, right? The curved
Yes.
line. This one. This is a great circle. The the terminology will be the great circle A to B at A. This is what you found. GC A to B at A. This angle was, if this is 60 degree, this is 7.5 degree, it came out to be
52.5. Okay.
So the answer you found out was for question number one.
Yes.
Okay. Now you have to find this question number four. Great circle A to B at B.
A to B at B.
Yes, A
Okay.
to B. Remember the direction. We are going from A to B.
At B, the angle is 7.5 no. Even, I mean, it's same.
Okay. First, let's start with this. You write down all the terminologies first. One here is rhumb line from A to B. Okay. Two here is great circle track or bearing from A to B measured at A. Three here is rhumb line from B to A. Four here is great circle
It's
track from
from B.
B to A, right? From direction B to A it is going at B. If I drew something like this, it is great circle track from A direction to B direction, but we are measuring it at B.
Okay. Okay. Okay.
You can take a screenshot of this one. It will be helpful. Or I will just share it with you later, whatever helps. Now let's move to the question. Now try to solve it.
From A to B at B. Sorry. A to B at B.
Yes.
Just from